When a 25.7 gram sample of sodium iodide dissolves into 80 grams of water in a calorimeter, the temperature rises from 20.5 to 24.4 degrees Celsius. Calculate delta H in kilojoules per mole for the process. So overall here, we need to use a couple of equations. We first need to use Q equals mc delta T, to figure out the amount of heat energy that's given off by this process. This is going to come out in joules because the specific heat of liquid water that we have is 4.184 joules per gram degree Celsius, and so this is going to come out in joules. Then we can take that number of joules, and we need to get the number of joules per mole, so we'll figure out the mass of the sodium iodide that we're dissolving, and then figure out moles of sodium iodide. And then finally we'll take the number of joules and divide by the number of moles to get the number of joules per mole, and then simply convert to kilojoules from there. And so this is a multi-step process, but the first thing that we need to do is figure out what variables we have here. So 25.7 gram sample of sodium iodide, so that's the mass of the sodium iodide, is equal to 25.7 grams. And then it dissolves into 80 grams of water, so we have a second mass here, the mass of the H2O, which is 80.0 grams of water. And when we use Q equals mc delta T, we're actually going to use the total mass because the heat is in both of these objects, so we need to heat up the water completely. We're actually going to make the assumption that the specific heat of the solution is the same as the specific heat of liquid water, of H2O liquid. We're going to use that same specific heat value for the whole solution. So we can add these up here. So 80 plus 25 is 105.7 grams. So there's our total mass that we'll use in our equation. Then we need the temperature change. So the temperature rises from 20.5, so that would be our initial temperature, 20.5 degrees Celsius. To our final temperature, it rises to 24.4 degrees Celsius. And so to get our delta T, we'll just subtract. So 24.4 minus 20.5 gives us a temperature change of 3.9 degrees Celsius. And of course we already have our value for C because we know that the specific heat of a solution can be generalized to the specific heat of liquid water. Okay, so now let's plug in and solve here. Q equals M, so 105.7 grams times C, 4.184 joules per gram degree Celsius, times our delta T, which is 3.9 degrees Celsius. And just taking a look at units here for a second, notice that the degrees Celsius cancel, the grams cancel, and our final unit that we're going to be left with is joules. Alright, so when we solve this out, we get 1724.8 joules, and since this is not our final answer, I'm not going to round this to sig figs, as we want our final answer to be in kilojoules per mole. So I'm going to go ahead and take this number of joules and convert it to kilojoules, so I'll do that in green. So joules to kilojoules is 1 kilojoule I know is equal to 1,000 joules, so essentially what we're doing is just dividing by 1,000 to get the number of kilojoules. So if we divide this by 1,000, that's the same as moving the decimal point 3 times, so 1.7248 kilojoules. And once again, this is still not our final answer, so I'm going to leave all the sig figs. We need the number of kilojoules per mole of sodium iodide that dissolves, and this is the whole equation only involves 1 mole of sodium iodide. So this is actually going to be the delta H value for the entire process as well. So to figure out the number of moles, I just need to take the mass of sodium iodide, so the 25.7 grams, 25.7 grams of NaI, and I need to convert this to moles. So grams to moles, and 1 mole of sodium iodide, I can add up its molar mass based on the periodic table. So sodium is about 23 grams per mole, and iodine is 126.9. So that gives me 149.9 grams per mole. So if I do 25.7 divided by 149.9, that gives me 0.1714476. And I could keep going, but actually when I substitute these values into my final equation to get the number of kilojoules per 1 mole, I'm just going to carry out the whole value from my calculator. And so I'm going to take my 2 values, this value up here and then this value down here, and we're going to simplify them down to get the number of kilojoules per 1 mole. So 1.7248 kilojoules divided by 0.1714447 moles. And if we simplify this down, let's see. And I'll take the values in my calculator exactly. 1.7248 divided by the exact number of moles, and that gives me 10.06 kilojoules per mole, but of course I am going to do sig figs now that I'm at my final value. And all of the values in the problem have 3 significant figures, so my final answer should also be rounded to 3 significant figures. So I'll do the rounding sign, and then I will round to just 10.1 kilojoules per mole. And I'm running out of room here, so I'm going to put it below kilojoules per mole. And there is our final answer.